Hi, and welcome back to another one of our practice problems from Newton's first laws. This time we're looking at position versus time graphs, the ever so baneful thing that a lot of people have trouble with. So let's jump right into it so that we can understand them. So here's our problem. We are given the graph of a motion of an object, and we're asked to find several things. We're asked to find the displacement at 3 different spans. We're also asked to find the average velocities at those same intervals, and we're asked to make a velocity versus time graph. So what do we need to do? So displacement is the change of position. So you'll notice up here that this is position, our x value on the vertical side of the graph. So what we need to find is how much does it change by. That's what displacement really means. When we go from 0 to 15 seconds. So when we look at this, we see that it goes up 60 meters, and we can very easily see that the answer to the first one is, in fact, 60 meters. Nothing too difficult there. Next one is asking between 10 and 40 seconds. So at 10 seconds, we can see it's up here at 60. And at 40 seconds, we can see that it is down here at negative 40 for its position. So here is where you need to be careful. What you need to do is displacement means to change in something. In order to find the change in something, you need to take its final amount and subtract its initial amount. It's the easiest way to do it. So we were at negative 40 at the end, and we are at 60 at the beginning. Negative 40 minus 60 gives us negative 100. Now for the last one, we are being asked about what is it between our initial times 0 and our 55-second mark over here. Well, we can see that they're at the same level. We don't even need to try to do any math with this one. If they're at the same level, it's going to be 0. Don't forget units on any of these. Units are always very important. Now, if we want to calculate the average velocities of these, it's actually not too bad. Remember that our average velocity formula is displacement over time. So for that first one where we had a displacement of 60, that occurred over 15 seconds. So 60 divided by 15 gives us 4 meters per second. Pretty straightforward. For part E, we're being asked about between that 10 and 40 second mark. And we went negative 100 meters of displacement during that time over 30 seconds. So negative 100 divided by 30 gives us negative 3.33 approximately. And again, that's in meters per second. Our last one, we had a displacement of 0. So you guessed it, our average velocity is also going to be 0. We ended up nowhere compared to where we started, so we were traveling at 0 rate. Even though it moved, it ended up back in the same spot. So effectively, nothing happened when we're just looking at the beginning and at the end. Now, here's the tricky one that people have difficulty with: creating your own velocity time graph from this. Now, the key here is to look back at our average velocity equation. That is displacement change in position, our vertical amount, over our change in time, which is our horizontal amount. That should ring a bell for you, because that is slope. So really, we're just asking you to make a graph of the slope. So we gotta start out with an axis set. This vertical amount would represent the velocity, this horizontal represents time, and you want to chunk this, break it into pieces that you can easily break down. So if we look at this first 10 seconds, the first 10 seconds, we see that rises up 60 over 10 seconds. So that gives us a velocity of 6. So it would be up here on the graph. Then we look at the next section. It's got this flat section of line. That slope, that's a 0 slope right there because it's not changing. So our next part of the graph would be 0. And you'll notice that I have the times lined up here so that you can see a good comparison between them. Then between 15 and 40 seconds, we can see that it is decreasing at a steady rate. It's actually decreasing at a 1-to-1 ratio. So we would see, well, 1-to-1 on the graph. Notice that these the boxes for the position here are not the same as the boxes for the time here. So it is down one box, which is 20, over the next section, which is 5 seconds. So that is 20 over 5, which gives us -4, which would be over there. That spans all the way to 40. And then this last piece here, we went all the way over for 15 seconds, and we rose 40. So 40 divided by 15 is going to give us approximately 1.6 or 2.6 repeating. So that would put it over here. Now this graph doesn't look like something that's very nice, because you wouldn't find something that's nice. You wouldn't find something like this in nature. You can't instantaneously switch your velocities like this. You cannot stop on a dime. There is always some distance involved with that. But this is what we are using for right now before we get into more complex graphs. I hope that you have understood these problems and that you find them fairly easy after watching this video, and I will see you in class.